Hello. In this episode, we're going to learn an example of separable first order differential equation. So to go over what is separable first order. So looking at the word, so this is actually a separable differential equation. So separable means you can separate. See, separable, you can actually separate x on one side and the y on the other side. So to be more precise, if you can rewrite a differential equation as on one side some function of x times dx, and on the other side some function of y times dy. In other words, all x on one side, all y on the other side, just like this. If you can do this, then it is separable. In the beginning, the question may not look like separable, but after you do a little bit of algebra, it will be. For example, sometimes you cross multiply, sometimes you multiply the numerator and denominator by something, sometimes you factor out and then cross multiply, depend on the situation. Now, once you have separable, how you solve? You simply take the integral of both sides. So if you have a separable differential equation, you take the integral on the left hand side, and that will be with respect to x, and the integral of the right hand side, that will be in respect to y. And each individual one, that's a calculus 1 and calculus 2 problem. You might have to use integral by parts, sometimes use substitution, and different techniques of integral that you learn. So let's look at this problem. So I'm going to copy this problem here. 1 plus y square. So here you can see I can actually simply cross multiply, right? So if I cross multiply, I get x squared dx on one side and 1 plus y squared dy on the other side. So it satisfies the definition of the separable differential equation, right? We have some function of x times dx, some function of y times dy. So let's take the integral of both sides. So the integral of the left is 1/3 x cubed. Now plus c1. That's going to be your constant of integration for the left hand side. All you always have to add c, right? I'm going to call it c1 because there will be a c2 for the right. And the integral of this side is going to be 1, so sorry, y. So the integral of 1 is y plus the integral of, so that's the integral of 1 is y, and the integral of y squared is 1/3 y cubed plus c. I'm just going to call it c2. And I want to make some comment about c1 and c2 a little later. So let's actually move everything to one side. So what I'm going to do, I'm going to just move all of this to one side. Okay, so let's do that. So I'm going to write 1/3 y cubed minus 1/3 x cubed. When I move 1/3 x cubed on the other side is minus 1/3 x cubed. Then I have plus y plus c2 minus c1 equal to 0. Just to make sure, so this I move it, so this 1/3 x cubed, I move it to the other side. This c1, I move it to the other side, right? Okay, very good. It's a good idea to write from the higher exponent to the lower one, right? So I write the y cube and x cube first and then write the y. It doesn't really matter. Now let's look at c2 and c1. What are c2 and c1? So c2 are arbitrary constant. It goes from negative infinity to infinity, right? Same thing for c1. So c1 and c2 are arbitrary number. It could be anything. So this means that c2 minus c1 also will be some arbitrary number. So as C2 vary from negative infinity to infinity, and as C1 vary from negative infinity to infinity, C2 minus C1 also vary from negative infinity to infinity. So why call it C2 minus C1? Why not? I'm just going to call it just C. So I can replace the C2 minus C1 by just one constant. Just call it C. At the end of the day, it's a number. Why call it C2 minus C1? Just call it C, right? So finally, what I have is 1/3 y cubed minus 1/3 x cubed plus y plus c equal to 0. Let us make some comment about this c. So this arbitrary constant c, so c is this arbitrary constant. C is any number, any constant, right? So when c is any constant, let's say c goes from negative infinity to infinity, right? If you add something to c, let's say c plus 10, I can actually replace that by c, because if c is any arbitrary constant, c plus 10 is also some arbitrary number. So why call it c plus 10? I can just replace this by c, right? If I subtract c minus 100 for the same reason, I can replace this by c. If I have 5c, I can replace this by c. If I have c divided by 9, I can replace this by c. Again, the same reason. Whenever I have an arbitrary number c, when you add some number or subtract some number or multiply by something or divide by something, at the end of the day, you get some arbitrary number and just call it c. Why call it c over 9? Just call it c. So c absorbs any constant. So if we add some particular number to c, or subtract some number from c, or multiply c by some number, or divide c by some number, you can actually replace those by just c. So c absorb any number. So this will be helpful when you simplify your answer. So for example, if I going back here, if I want, I can bring this c to this side, right? If I want. So I'm going to get 1/3 y cubed minus 1/3 x cubed plus y equal to, when I move this c to the other side, it becomes negative c. But why write negative c? Your negative c is actually just c, right? Because if you multiply, negative 1 times c, it's just c. It absorbed that negative 1. So I can just replace that by c. So typically, we move the constant on the right hand side. So this is, this just looks good. And this is a solution. So this is the solution of this differential equation. So I'll copy it here. 1/3 y cubed minus 1/3 x cubed plus y equal to c. So this is an example of an implicit solution. Implicit means the y is not given in terms of x, or y is not solved in terms of x, right? So here y is given implicitly, right? So here, so implicit solution means y is not solved in terms of x. So y and x mixed together in one equation. So y is not solved in terms of x. So that's called implicit equation. And if y is indeed solved in terms of x, then that will call explicit equation. So compare this with an explicit solution or explicit equation. So an explicit solution, as an example, something like y equal to x squared minus x plus c. That will be an example of an explicit solution. Of course, that is not the solution of this problem. So I'm just giving an example here. So this one is explicit solution. So explicit solution means y is solved in terms of x. Finally, let me make one comment here. So from now on, when when you're taking integral of both sides, instead of adding c1 on one side and c2 on the other side, you just add c on one of the side. So you choose which side you want. You just choose c on one of the side, because we know when I move c1 and c2 to one side, I can replace that by c. So do not add c1 and c2. Do not add the constant of integration of both sides. Just add in one of the side, and that will be okay. So from now on, when we are going to take integral of both sides, we will only add c on one of the side, not both, just to simplify our life a little bit. So to summarize, we did an example of a separable differential equation. We learned about what is separable differential equation. We did one example of this separable differential equation. We learned that we just need to add c on one of the side, not in both. We learned about the explicit solution versus implicit solution. So this one is implicit solution here. We also learned about that this arbitrary constant c can absorb any constant. Thank you. Bye bye.